Yeah, then comes this question. It says that at T3, which is this time, the concentration of hydrogen was increased. Okay. Let's draw the graphs to show the changes in hydrogen, nitrogen, and ammonia. Okay, what do we see here? We are increasing our hydrogen. So we show it by that spike. But to predict this, let us have the equation. The equilibrium is Na2 plus 3H2 giving you our ammonia. And what are we doing? We are increasing concentration of hydrogen. So it's increasing. Now, when you increase concentration of hydrogen according to Le Chatelier, you are disturbing the equilibrium, and the equilibrium does not want to be disturbed. So what happens? There's a tendency for this concentration you have increased to decrease. And how does that happen? By this excess reacting with nitrogen. So what will happen to our nitrogen? It will decrease. Now, when hydrogen and nitrogen react, they form ammonia, so ammonia increases. So those are the changes we are going to show. So let us start with our ammonia. What happened to ammonia? It increased. So we are going to show it like that. Okay, what happens to nitrogen? Nitrogen is A. It decreased. So we are going to have it like this. And our ammonia, it spiked up, but because of the tendency to restore stability, it decreased a bit. And that is what happens. Yeah, then comes this question saying predict position of equilibrium. Okay. So what do? We have our equilibrium, which is that. So what is the change? The change is hydrogen increasing. So we have it here. And we said when hydrogen is increased, the equilibrium is disrupted and it needs to be restored. So what happens? Remember, whatever you do is supposed to be opposed. So when you increased hydrogen, there's a tendency for it to decrease. And how does it decrease? By reacting with the nitrogen. So nitrogen decreases. And when this and this react, they form ammonia. So ammonia increases. Now you need to know that the position is always from low to high. So that's the position. And what is that one? That is forward favored. So you say forward reaction is favored. Yeah, then comes this question. It says that at T4, which is this time, the concentration of B was increased. They say, let's draw the graphs to show the changes in hydrogen, nitrogen, and ammonia. So we are here now. And what are we saying? Concentration of B is being increased. So when you look at here, which one is our B? You trace it, it's here. So when you increase B, what will happen? Like I always tell you, to predict this one, you need to have the equilibrium. So this is the equilibrium you're having, which is nitrogen plus hydrogen, giving you ammonia. Okay. You know the graph to show the changes in this. So what are we doing? We are increasing B. B is ammonia, so we are increasing it. Okay. Now you need to know that when you increase ammonia, you are disturbing the equilibrium. And the equilibrium doesn't want that according to Le Chatelier. So what happens? Whatever you increase here, it will be reduced. But how is this one reduced? By forming this and this. So in other words, this will increase and this will increase so that this one drops a bit. Yeah. So how do we show that? We are seeing nitrogen increasing. What is our nitrogen? Nitrogen is A. It is this one. It will increase. And our hydrogen will also increase. And our ammonia, it will drop a bit. So that's what we have. These are the graphs we realize when we increase the concentration of ammonia. Yeah, then comes this question. It says that predict the position of the equilibrium. Okay, we have the equilibrium. It is N2 plus 3H2, giving you 2 ammonia. So what are we having here? We are increasing ammonia. Okay. And doing that is tantamounting to disrupting or disturbing the equilibrium. So what will happen? The equilibrium reacts by decreasing the ammonia you have increased. How does it do it? It does it by forming our reactants. So that's what happens. Because of that, this one drops a bit. Okay. Now they want us to predict position of equilibrium. Position is from low to high. So it's going to be like that one. And what is that? Reverse is favored. So that's the answer. Reverse reaction is favored. Yeah, then comes this question. It says that state what happens to the rate of reaction. Okay, we need to know that we have just increased concentration of B, and B is ammonia. Ammonia is the product. So what happens to the rate of reaction? I need to remind you that increase in the concentration of either product or reactant increases rate. So the answer will be increase. And with that, I would like to Thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. Don't forget to subscribe, to comment, to like, to share. And we need also to remind you that Physical Sciences Silver Bullet is a YouTube science channel dealing with physical sciences grade 12, 11, and 10, and natural sciences grade 8 and 9. And we advise you that because of the scope of this channel from grade 8 to grade 12, when you go to the channel, don't go to videos. Just go straight to playlist. And then you choose the material of your level. For grade 8 and 9, each one is presented as a tile. Grade 8, natural sciences. Grade 9, natural sciences. For grade 11 and grade 10, each one is a tile as physical sciences grade 10 and physical sciences grade 11. For grade 12, each topic is a tile. So just go to the topic and press and click the button. Then all the information for the topic will be revealed to you. See you then. Bye-bye.